All right. Here we go. We got 1.12. So we got our first Explorer question. There are multiple parts, so make sure you reference your book for this. Okay. I just split it in 3 slides so I can see all of it. Okay. So it says that the ticket price for one-day admission has steadily increased each year at many theme parks, including Disneyland in Anaheim, California. Never been to that one. Ticket price for one-day admission at Disneyland. Okay, and you see how much it increases from 2000 to 2016. All right, so at what percent did the price increase from 14 to 15? So if I look here at 2014, it looks like the price is $96. And then 2015, it looks like it's $99. Well, luckily this is, within 100, out of 100. So technically we don't have to, we just think about logically. How much should it go up? It went up $3. So it went up 3. We're going to get into the nitty gritty of how to calculate that. When it's not as, as simple as like out of 100. All right. So we're going to use in part B, it says use your answer from part A to forecast the ticket price in 2016. Well, if I went it up $3 from 14 to 15, then I'm going to assume, based off what this question is asking me, that I'm going to go up $3 from 15 to 16. So 99 plus 3 is 102.1. All right. Okay. Hold on. All right. Sorry. Had a little lag going on. Here we go. Next one. Same question, different part. Between 2000 and 2015, by what percent did the ticket price increase? So 2000, it was $43. All right. And in 2015, it was $99. So this is kind of a preview of what we're doing today. What I would do is, I don't know if I want to. Well, I can say this. We know that this is going to be over 100% increase because 43 times 2 is 86, and 99 is obviously bigger than 86. So the question really becomes is how much over 100% is this of an increase? All right, is it 150? Is it 120? 110? 200? Whatever. All right. The way we're going to find out this is about a sneak peek of something I'm going to do later in the lesson. Is I'm going to do 99 divided by 43. So I'm going to do my final amount divided by my starting amount. Okay, 99 divided by 43 is going to be a lot. Whoops, sorry. 99 is 99 is 2.3 something. Well, that's obviously over 1. Okay, 1 would be 100%. All right. So if I subtract 1 from that, I get 1.3, which means this is 130% increase. Now, why did I subtract 1? Well, I'm taking away the one piece, the 100% of this thing that I started with. I started with $43, so I take away that $43, and what am I left over with? You're actually left over with $56, which is 43 plus 30%. Okay, that's a little confusing. This is a tough thing to conceptualize initially. We're going to get to this more, and I'll give you a better explanation than that. All right. So this is what we're talking about. Can you increase or decrease the number by a percent in one step? All right. Is a 200% increase the same as doubling or tripling a quantity? And then, do you know how y changes are often stated as a percent change? All right. So there's a couple different ways we can increase a number by a percent. This outlines the 2-step process. All right, the 2-step process logically to me makes more sense. However, it takes longer. Obviously, it's 2 steps as opposed to 1. All right, so we want to get in the habit of using the 1-step process. All right, in the 2-step process, all I do is take 5% of my initial amount and then add whatever that was to the initial amount. Okay, in the 1-step process here, all I have to do is if it's a 5% increase, increasing by 5% means finding 5% of the original. So of the 100%, then adding 5% to the whole. That is 100% plus our 5%, okay, to give us 105. And the picture is showing the addition of 5% in the rectangle, representing 25,000. All right, 5% adding it to the base are 2 steps, whereas 105% requires only 1. So if I multiply this by the 100 plus 5 percent, so like 1.05, why can't I just multiply it by 105? But because remember, we represent our percents as decimals, okay? So I divide by 100. 105 divided by 100 is 1.05 to get 26,250. Therefore, to increase a number in one step, we can multiply a number by 1 plus the percent as a decimal. This is known as our multiplier. You can also do the same process if we want to decrease a number by a step. So decrease $100 by 5% using the 2-step and 1-step process. This is an important sticky note over here. I'll talk about that in a minute. So to use a 2-step approach, I'm just going to take 5% of 100 and then take that off. All right, this is like as if you had like a 5% discount on something, okay? I take 5% off of that. Another way to do it, though, is to use the 1-step process. So what that means is I started with 100%. I'm taking off 5%. I'm taking off 5%. So really, I want 95% of my original price. So my multiplier is 0.95. And look, I still get the same answer. Remember, I'll say that one more time. I start with 100%. That's my true price that I begin with. I'm taking off 5, which means I really want 95% of my original price. And 95% as a decimal is 0.95. For a percent increase, the multiplier will always be greater than 1, since I'm adding additional percentage to my 100. And then for percent decrease, my multiplier will always be less than 1, since I'm taking away from my 100%. All right. So we want to find the multiplier. We're not going to multiply by anything. We just want to think about what this means. Okay. So if I'm increasing, all right. In our last slide, I said, if it's an increase, your multiplier should be greater than 1. Well, I'm increasing by 22%. So really what this logically means, and you don't have to write this part down if you don't want to, I'm doing 100% of what I have plus 22% of the increase. So really it's 122%, which my multiplier would then be, divide that by 100, the multiplier would be 1.22. Okay, if I decrease by 22%, this is the same process. I'm doing 100 minus 22, okay, which is 78%. So I think about that as 0.78. All right. And obviously, if we wanted to increase by 22% of something, we'd multiply by this and decrease likewise. We're going to try one of these. All right, this is just exactly what we just talked about. All right, how it works. You have this as a resource. Okay, so let's talk about this. At your job, there are 2 proposed pay raise structures offered by management to a labor union. A labor union has to vote on which one to use, but different members of the union have different opinions based on the effect of the options will have on their salary. The union's leadership has to determine which option is best for who. All right. Even though that in a labor union might be presented with more than one pay structure when you're offered a job. Okay. Many employees negotiate their salaries on an individual basis, so being able to determine which structure is more beneficial to you is actually a very valuable skill. All right. So this is something that you can do later on in your life. Okay. All right. Or maybe you're working. Obviously, we have a lot of people working right now. All right. A lot of times jobs have set pays. Okay. But if you have an opportunity to negotiate a pay or a pay raise or whatever that may be, this is how you might do it. All right. So what we want to do is we're going to go each. This is going to be a lot. here. Just forewarning. All right. We're going to do a lot of writing here. Okay. There is an easier way to do this. Yeah. You know what? Hold on a second. All right. So I'm going to think about this. So we have our new salary. There's option 1, which is a 5% increase, or option 2, which is a 3.5% increase, and then I add on 1,000. Okay, and then we'll find the difference. All right. So I want to think about this. I'm going to write this in terms of an equation because that's how I think, because I'm a math guy. Just so we have like what we're going to be doing each time. Okay. So if it's option 1 is a 5% increase, that means it's going to, my multiplier is going to be greater than 1 since it's an increase. All right, well, how much greater? Oh, 0.05 since it's 5%. Remember, 5% as a decimal is 0.05. So all I'm going to be doing for each of these, every single one of these here, I'm going to be taking the current salary. So I'm going to call this salary S because that's a salary. All right, and I'm going to multiply it by 1.05. So for every single one of these, I'm going to do 1.05 times. I would love to be able to close that up. There it is, times S, times our salary. I kind of had to make that a little tail like that just because, so you know the difference between S and 5. All right, so I'm going to do 15,000 times 1.05. Okay, and then I would get my number. So I got buckets. I got 15. All right, then I'm gonna do the same thing with 18,000. 18,000. That's gonna be 18. Holy buckets! I'm gonna lose it. 18. 100. Holy buckets! Got to do the same thing for 20,000. So, all right. So what I want you to do, pause it. I'm going to fill this in and compare your work to what I got. Okay. So if you take a second and check your work, or maybe write this down. Okay. These are the numbers that I got. Basically, the most important part here is understand that I do 1.05 times this salary amount. Okay. Next one. All right, next one. What I want to do for this next part, okay, let's try option 2 now. All right, it's a 3% increase plus $1,000. So, excuse me, 3.5. So 3.5 is a decimal, is 0.035, right? So I'm really going to do 1.035 times my salary, so S, plus, then again, I have to add that 1,000. So I'm going to add the 1,000 at the end. All right. So I'm going to plug this into my calculator. 15,123 times, holy buckets, 15,123 times 1.035, then plus 1,000. And I got 16,525. All right, I'm going to pause it again here, fill these out, and we'll compare. Alrighty, so here we go. Here are our new numbers there. Okay. Take a second there. You can pause it for now. And what we're going to do in this last column, all right, is I'm going to do the difference. Okay, I'm going to find the difference between option 1 and option 2. All right, so I'm going to subtract option 1 from option 2 here. Okay, so like 15,750 minus 16,525. Now, here's the deal. It may be a negative number, and that's okay. That's going to help us answer some of the questions later on. Okay, so go ahead and let's do that. Wow, a lot of calculations here. Okay, here's what I got. All right, take a minute. You can pause it and write those down. All right, remember I did option 1 minus option 2. Okay. All right, list the names of employees who benefit more from option 1 than those who benefit from option 2. All right, so what that means is list the ones who benefit more in option 1, and then list the buckets, and then list those. Sorry. Okay, we're back. So option 1, who benefited from option 1 as opposed to option 2? Option 1, there were 2 people. How do I tell? Well, there's were pluses. So Evelyn and Emily were the only 2 that benefited from option 1. A difference there. So Evelyn, how do you spell it? Evelyn, and then Emily. Okay. Option 2. There we go. Option 2. Literally everyone else. All these people. John, Marissa, Jay, Carrie, Bob, Paul, Leah, or Lee, and here we go. So John, Marissa is spelled one N, I-S-S-A, Carrie, and you can write everyone else if you want. I'm just going to write everyone's name out because I'm fun typing. It. All right. What does the result in the difference column mean for John? Okay. So what does it mean for John? So let's look at the difference column for John. John has negative 775 here. So he will make what? He will make less in option 1 than option 2. So John will make less. John will make $775 less. Emily will make $425 more in option 1 versus option 2. Now, why is that? Because after a certain point, okay, well, I think that's actually a question, so I don't want to give that away yet. Just not tell you. In general, which salaries benefit the most under each option? So I kind of alluded to that in general. Option 2 is better for lower salaries, and option 1 is better for higher salaries. So option 2 better for lower salaries. Option 1 better. And the next 2, is there a way for these to be the same? Yeah, there will be a way for that to happen. State the range. Okay, we're good. That's enough about that. All right, we got to keep moving. Okay, so a salesman starts here with 200 clients and ends it with 260. By what percent? So we're figuring out the percent increase before we were given the percent increase. All right. So there's 2 ways you can do this. All right. There's always a 2-step process there. Okay. If I do 260 divided by 200, I get 1.3, which means there was 130% increase because it's 0.3 or 30% over 100. All right, we're going to only focus on the 1-step process. All right. So the book gives you a chart on how to calculate each, on how it works. All right. So, but we always want to do our final value divided by our initial value. Okay. All right. So we want to fill in the table. Sorry, my legs are spasmed. Here for the pounds lost. So let's look here. The husband 380 minus 366. He lost 14. And then the wife lost 10. And then it asks for the percent of weight loss. So I do the final divided by the original. All right. And so what I did when I got that, I got 0.963. Okay. So that tells me it's going to be a percent decrease. Obviously, this is going to be a decrease because of the fact we're losing weight, right? But it's a percent decrease because this value here is less than 1. So to find the percent that I'm decreasing, I'm going to do 1 minus this value Okay, so 1 minus 0.963 gives me 0.037. And if I multiply that by 100, that's 3.7%. Okay, same idea here. 190 divided by 200. Oh, my calculator just died. Oh, it just died again. So I got 0.95, and then 1 minus 0.95 means I have a 5% increase. Okay, using information from the table and determine which of the following statements are true. The husband lost more pounds. True. The wife lost at a higher percentage. Lost weight at a higher lost a higher percent of her weight. True. She lost 5% compared to 3.7. The wife's new weight is 95% of what it was originally. So our original weight was 200. 95% of that is actually 190. How do I know that? Because of this number here, the 0.95. All right, so that is true as well. The wife's starting weight was 5% more than her ending weight. That's not going to be true, and that's a little confusing, but that is false. That is false. All right, so the placement, yeah. So I would do, just to figure out the percent increase in this one, I would do 400 divided by 200, and we realize that is 2. So really, that's 1 more than 2. You know what I mean? So on the last couple, we've subtracted 1 minus the end. So I'm going to do 1 minus this, or 100% minus 2 is 1, or negative 1, right? So it was 100% increase, all right? Because this number is 1. Okay. The new price is double the initial price. Is that true? Well, yeah. I mean, yeah. There was a 200% increase in price. No, it was 100%. The new price is 200% of the original. That is true. Okay, because this is 2. All right. It's not a 200% increase. It's a 100% increase. Okay, because I have to take that 100% off, but it is 200% of the original price. All right, that's a long video. I apologize for that, but that's it.